In this video, we'll discuss the key components of an irrigation system, covering everything from water sources to the products and components that are built into an irrigation system, including water meters, valves, piping, sprinklers, controllers, sensors, and more. But before we discuss the physical products that are used in an irrigation system, let's remind ourselves and future customers what the reasons are to have an irrigation system in the first place.
A professional automatic irrigation system is designed to ensure different plant types get the correct amount of water they need. Automatic irrigation systems save time by letting the technology handle the routine and time-consuming process of watering landscapes. A modern system saves money by adjusting watering schedules automatically when the weather changes. A professional irrigation system prevents tripping hazards by moving the water throughout the property while being out of sight and out of mind, with no messy hoses laying around for someone to trip on. And being underground, the system of pipes and spray bodies are protected from seasonal weather and routine maintenance. The main reason for having an irrigation system is to help provide a beautiful landscape. This can increase property value and have a positive effect on your quality of life.
Now, let's go through and identify the components of an irrigation system. An irrigation system is comprised of many components. Each component serves a unique purpose in the functionality of an irrigation system. All irrigation systems require a water source. It may seem obvious, but it will be very important to know where the water is coming from, so make sure to verify the water source before beginning your installation.
Water sources may vary from site to site and region to region. The water source might be delivered in a network of pipes that run under the roads that we drive on every day. This network of water pipes is referred to as service main lines. Water can also be pulled from the ground or surface water sources like ponds, lakes, streams, and rivers using pumps to create the pressure needed to operate the sprinklers. You may have a municipal connection, like a metered potable water service or a metered recycled or reclaimed water service. In this example, the water source is a municipal metered potable connection. With a municipal supply, pressure is created in the water supply lines by pumps or by gravity-fed supply tanks on hilltops or water towers you see throughout cities. These are maintained by the supplying agency. The network of pipes deep under the city or county roads service homes, commercial properties, and fire hydrants. These pipes are usually very large and typically range from about 2 to 36 inches. These are called municipal main lines and may often be referred to as city main or main line. A saddle tap is installed on the city main line to access the water and deliver it to a property through the service line. Between the city main and the water meter, you may find a curb stop. A curb stop is an outdoor isolation valve where the water provider can turn water on or off for a property. This is usually found in a valve box just inside the property line. In cold weather climates, this valve is deep in the ground below the frost line.
The water then passes through the service line to a water meter. So what is a water meter? The water meter reads and records all water being used on the property. Before the water can be used on the property, it must pass through a water meter to track the quantity of water used inside the building or out in the landscape.
In many areas, one water meter is installed to service both indoor and outdoor water use. Other areas may require installation of 2 water meters, one for indoor use and one for outdoor use. One advantage to having a dedicated irrigation meter is to eliminate costly sewer fees commonly incurred with indoor water use meters. This is because water that enters the home is assumed to leave the home and go into the sewer system, and water used by the outdoor irrigation system is assumed to stay in the landscape. Another advantage is that it allows measurement and therefore better management of landscape water, maximizing efficiency and helping to ensure a beautiful and healthy landscape. Meter sizes range from 5/8 inch to 1.5 inch for residential properties and can range from 5/8 inches to 4 inches or larger for commercial irrigation systems. A typical warm weather installation will have a meter box where water comes from the city main through the water meter to the delivery line. For cold climates where freezing temperatures are likely, the water meter may be placed inside the building.
After the water meter, the water moves through the delivery line to provide water to the house or building.
A point along the delivery line is chosen to be the point of connection or POC for the irrigation system. Typically, this is where the irrigation system starts. Water is directed to the irrigation system from the delivery line that supplies water to the home or commercial building. This will be different if the irrigation system has a dedicated water source separate from the meter to the home. In warm climates, the POC is usually before the building, and in cold climates, the POC could be inside the building. At this point, a compression or slip tee is installed at the POC. The tee can be made of various materials. Check your local codes for the appropriate type used in your area. Note that in cold weather climates, an additional quick connect type fitting and drain valve should be added to the point of connection for winterizing the irrigation system. Most cities require the use of a device known as a backflow preventer to prevent contamination of the potable water source by ensuring that no water that has been directed to the irrigation system can make its way back to the delivery line or municipal service line. The three most commonly used are a pressure vacuum breaker or PVB, a reduced pressure zone or RPZ, and a double check assembly or DCA.
After water passes through the backflow prevention device, internal check valves prevent water from flowing in the opposite direction. The installation of this device is often required by local code and typically requires a licensed professional. Check your local code to determine which backflow prevention device is required for your system. After the water meter and the backflow preventer, there might be a pressure regulator to regulate the pressure to the entire system.
A pressure regulator should be installed if the incoming pressure is much higher than the system requires. There are other products that can be used in the system to help regulate pressure, such as pressure regulators for control valves or pressure-regulated sprinkler bodies, but those should not be a substitute for pressure regulation at the point of connection.
After the pressure regulator, an optional and highly recommended device known as a master valve can be installed.
The master valve, in most cases, is simply a control valve located after the POC. There are both normally open and normally closed master valves. Since a normally closed master valve is the one most commonly used in smaller irrigation systems, we will be referring to that type during this training. A master valve is installed to avoid keeping the mainline and zone valves under constant pressure. We do this to prevent damage to the property created by irrigation mainline leaks. Its location in the system is what gives it the designation of master valve. For example, you may use a Hunter ICV for both a station valve as well as a master valve. The master valve must activate simultaneously with any station valve for water to flow through the system. Another highly recommended device, known as a flow sensor or flow meter, may be added to the system to monitor for high, low, and unscheduled flow. A flow sensor or flow meter, in combination with a master valve, can help to identify failures in the piping system and shut down the system, preventing water waste and high water bills.
Downstream of the master valve and flow sensor is the sprinkler mainline.
The sprinkler mainline is the largest pipe in the irrigation system. If there is no master valve, this pipe is typically under constant water pressure at all times throughout the entire site 24/7. The mainline delivers water to each of the zone valves throughout the irrigation system. PVC pipe is the most commonly used pipe for this, but in some areas, polyethylene, also known as poly, or high-density polyethylene, or HDPE, might be used. If a normally closed master valve is installed, the mainline only remains under pressure during scheduled irrigation cycles. Along the mainline and before the valve manifolds, it's recommended that shutoff valves be installed to isolate sections of the system for maintenance and troubleshooting. These are generally the same size as the line they are on. They can be made of PVC or brass depending on the system design and specifications.
The mainline connects to the valve or valve manifolds. Valve manifolds are a grouping of valves that control water flowing through the zone or stations on a property. Sometimes these are called automatic control valves, remote control valves, or electrical zone valves.
Electrical zone valves are installed to control the water flow to the sprinklers in each zone. Only when the controller sends a 24-volt alternating current electrical signal to open the particular valve will that valve open and allow water to flow from the main line through the lateral lines to the sprinklers or emitters. The piping system before the electrical valves is referred to as the main line, and any pipe system after the electrical valves is referred to as lateral lines. Lateral lines connect all the sprinklers on one zone and allow the water to flow from the valve to the sprinklers in the zone. When the valve opens, the lateral line fills up with water and the sprinklers pop up, or the drip lines are filled with water and build pressure to activate the emitters.
So, what is a zone? A zone is an area with similar plant material, sprinkler types, and sun exposure. Zones, stations, or circuits are common terms used to describe a specific area to be irrigated. In this training, we will use the term zone.
Areas throughout the property are divided into multiple zones depending on water capacity and the landscape needs. Each zone will have its own valve, lateral lines, and emission devices. Emission devices include, but are not limited to, bubblers, drip, MP rotators, and rotors like the PGP or I-20. The type of device needed is dependent on the size of the area and plant material to be irrigated. It is also important to consider available water pressure and maximum available flow when considering an emission device or other components.
Valves don't just operate on their own.
They operate open and closed to allow or stop water flow via a 24-volt alternating current electrical signal sent on a wire from a controller to the solenoid on the valve. The controller is the electrical device that sends the 24-volt signal to the valve that is programmed to open. The controller hosts the programming for the irrigation system. Once the controller is properly set to automatically irrigate the landscape, only minor adjustments should be necessary. It's important to adjust your controller seasonally to maximize water savings for your customers. Some controllers use weather data received from the internet to change the schedules based on the climate conditions. The controller is connected to the electrical zone valve through insulated heavy-duty wires. The valve has two wire leads coming out of the solenoid. One is known as the hot, the other is known as the common. The hot wire from each valve is directly connected to each of the individual station terminals at the controller, while the common wire is common to all stations. A common practice in the industry is to use white cable to differentiate common wires from the rest of the colored hot wires. This is connected at the common terminal at the controller and goes out to the field where all valves get connected to the single wire.
So we have the piping system moving water through the property and a controller that runs the programs operating the valves. The valve sends water through the lateral lines to their zones where water is emitted by a device like a spray or a rotor. Let's describe what these different water emitting devices are called and how they get water into their zones.
When water is available to the sprinklers or other emission devices, they irrigate the designated area. Pop-up sprinklers include rotors, sprays, MP rotators, and bubblers. Other emission devices include point source or inline drip irrigation. Pro spray heads cover short to mid-range areas between 2 feet and 17 feet and apply water at a relatively high application rate. Spray heads have been the preferred method of overhead irrigation of smaller spaces for decades. MP rotators are another form of overhead irrigation designed and used in short to large radius areas from 6 feet to 35 feet. MP rotators are a type of highly efficient rotary nozzle that fit on pro spray bodies and shrub adapters. MPs apply water at a much slower application rate than traditional sprays, allowing water to penetrate and move through the soil before it runs off the target irrigation area onto hardscapes. Rotors are known to be a large area type sprinkler and have a radius range from 15 to 103 feet. You will typically use PGJ, PGP, PGP Ultra, or I-20 for these large areas in residential or commercial applications. Rotors apply water very slowly and tend to be considered more efficient than sprays, but will require longer run times to adequately irrigate a given area. In this example, Station 1 is a PCZ drip control zone kit that includes a filter and pressure regulator. It's important to use a filter and pressure regulator when installing micro-irrigation components, as they require lower operating pressures and have small openings that could become clogged with debris in the water. Refer to the Hunter catalog or Hunter website for a full list of micro-irrigation products. Station 2 is an example of an MP rotator zone with head-to-head coverage. Head-to-head means that the heads are spaced so that one head's water throw reaches the adjacent head. Head-to-head spacing results in even coverage of water so that all plant material in the zone receives the same amount of water. It's important to note here that no other sprinkler types are being used with the MP rotator, and only similar plant material is being irrigated. This is an example of a station with proper hydrozoning. Remember, a hydrozone is an area of similar plant material being irrigated by the same type of emission device. Station 3 is an example of a gear-driven rotor zone. You'll want to use the same brand and type of rotors and select the proper nozzles. This is also an example of a station with proper hydrozoning. To activate any of these valves, a 24-volt alternating current electrical signal is sent to the valve from the irrigation controller. The signal is sent through a set of station control wires to open the valve solenoid, which allows water to flow through the valves, through the lateral lines, and then to the sprinklers or irrigation devices. The flow sensor or flow meter will receive its own set of wires separate from the valve wires.
There are a number of accessories that can be used in an irrigation system, such as rain sensors, remotes, pressure regulators, etc. For this introduction, we are focusing on the main components that make an irrigation system functional. More information about these products will be discussed throughout the rest of the videos in this series. To recap, an irrigation system begins at the point of connection from an incoming water source.
The water is moved through a master valve to a main line that then makes its way to a valve manifold group of zone valves. Each zone valve has a solenoid on it with wire running from the controller that receives an electrical signal to open and close the valve, allowing water to reach its zone of sprays, rotors, or drip products that irrigate different parts of the landscape.
Because different zones might need different water pressures, some valves are pressure regulated, while in other zones the pressure regulation may occur at the sprinkler body.
Different climates and areas dictate different irrigation practices, such as performing winterization of the system or different sources of water supply. Automatic irrigation systems are controlled by irrigation controllers, which send electrical signals to the valves to run a zone, and they may have wires connecting to the controller from flow meters or weather sensors that tell the controller information or to adjust or suspend irrigation.
These many parts and devices make up an irrigation system. Once installed, routine maintenance and adjustments are recommended to ensure the system runs optimally for many years of use.
Note that a wide variety of other irrigation devices are available from Hunter Industries, including rotors, MP rotators, fixed or adjustable sprays, micro sprays, inline drip, point source drip emitters, and root zone watering systems. For more information about these topics and our products, visit hunterindustries.com.
We will discuss the terms mentioned here in more detail throughout the videos in this series. Thanks for watching, and make sure to watch other videos and training modules offered through Hunter University by visiting training.hunterindustries.com.